Okay, let's play a little bit more with signal. What we're going to do here is still relatively easy. Okay, it's just arming a signal handler and doing very little with it. However, we are going to do it across different processes, and this is meant to show you that while pipes are meant for communication only between parent and child processes, signals can be sent to any process. So we are going to compile 3 different programs, program 1, 2, and 3, and pretty much what's happening is that you start those programs in 3 different windows, and I'm going to show you how, and then you give the PID of, for example here, you give the PID of program 3, process 3, which is going to be displayed when the process starts. You give this PID when process 2 asks it. You give PID of process 2 when process 1 asks for a target, and therefore process 1 will send a signal to process 2 because you just give it its PID. When process 2 receives the signal, it's going to send a signal to process 3, which is going to terminate. So all processes are just going to start, display their PID, then they are going to wait for you to give them the PID of their target process, and once you have done that for process 1 and 2, the cascading start. Process 1 send a signal to 2, 2 send a signal to 3, and 3 terminate, 2 terminate, 1 terminate. Okay, so this is relatively easy. It's just going to illustrate how we can use process to do inter-process communication between unrelated processes. So let's have a look at the code. I have already some boilerplate code here. Let's take a look. Program 1 is starting by displaying some information about itself, asking for the PID of its target, program 2. So I have here a target variable, I scan a value, and then I'm going to say I'm sending signal sig USR1 to program 2. How do you do that? Kill system call. Okay, kill system call is going to say I want to send to that specific target this specific signal. So what is asked of us is to use the signal sig USR1. Once I'm done sending the signal, there's no backslash in here, I display done at the end of the line, go to the next line, and I'm done with my job for program 1. Program 2 has a little bit more to it because program 1 is just a sender. Program 2 is both a sender and a receiver. So program 2 will have to have a function, a signal handler function, which I call sh underscore sigusr1, signal handler for sigusr1. The signal handler will say, well, as soon as I receive sigusr1, I'm going to send signal sigusr1 to program 3. So I'm going to do it the same way. I'm going to send to my target sig USR1. How do I know which is my target? Well, I have a global variable here, target, that's going to be accessible therefore to every function, including the signal handler. This variable will have to be set by the main. So the main is starting by saying, hey, this is me, program 2, this is my PID, so you can give it to program 1. What is the PID of program 3? You give a value, enter, this value is stored into the target. And then I need to set up a signal handler for sigusr1 because I'm not going to send sigusr1 to program 3 until I got it myself from program 1. So this is exactly what we used before. Okay, it's relatively easy. Now it's kind of a recipe. Set declare a variable of type struct sigaction, set everything inside this structure into 0, then use the only field of that structure we are going to deal with for now to the name of the function, the address of the function sigusr1, and then call the system call sigaction to indicate that when sigusr1 is received, we want the handler specified in this struct to be used, and we don't care about saving the current status disposition of the signal. So there we go. Okay, very relatively easy code. I'm saving this. Go to program 3. Program 3 is just a receiver. So program 3 is going to have a signal handler which, when it receives sigusr1, just exit the process. So what we have to do here is really similar to what we did with program 2, and I'm going to go ahead and do here a cut and paste. We are going to set a signal handler Okay, when we receive SIG_USR1, the function sh underscore SIG_USR1, signal handler SIG_USR1 is going to be called, and this is pretty much it. So let's save this. Let's go to Conqueror. We are going to need more than one console to test that application. So let me open a terminal here. Here is our terminal window. And in the menu session, you can open new tab into this console. Okay, so you have here 3 different consoles. Okay, well, what we are going to do is we are going to rename them even for more clarity. This first session is going to be prog1. This one is going to be prog2. So I'm going to run prog1 in the first tab, prog2 in the second, prog3 in the third. And I'm going to do that after I'm done compiling them. So here are the compilation line that you need to call. Compile all of those programs. We don't seem to have any syntactical problems, so that's already a good start. Let's go back to the multiple consoles and let's start them all, each in their tab. So I'm going to start prog1 here. PID is 2548 and it's asking for the PID of prog2. Well, hold on a minute, I don't have that yet. So I'm starting prog2. PID is 2549, it's asking for PID of prog3. I'm starting prog3. PID is 2550. And this one is sitting waiting to receive SIG_USR1. So 2550 is the PID of prog3. Well, let me give it to prog2. Prog2 is now waiting to receive SIG_USR1 to send SIG_USR1 to prog3. Nothing happened yet. PID of prog2 is 2549. So what is it? 2549, yeah. 2549 is going to be the PID I enter here. Enter. And then everything is going to happen real fast. Program 1, process 1, is sending signal SIG_USR1 to prog2. Done. Prog2 receives SIG_USR1. In response, it sends SIG_USR1 to prog3. Prog3 receives SIG_USR1. Prog3 is done. So we have our little cascading effect here that occurred among all of those independent, unrelated processes. And this is a code to achieve that.